Okie doke. So now I've hooked up this joystick, and I'll try to set this up so we can see. Notice on this I've only got that motor hooked up. Everything else is just a separate thing. Only these two wires are running to that desoldered motor. First I'll show you my little code. So that's the whole code, and what it does is it maps the potentiometer voltage reading to a range, and then this range, Arduino has pulse width management outputs possible from 0 to 255. My motor doesn't spin unless it's like 50 anyway. So anything between negative 50 and 50 on this range, I output 0. But if it's below negative 51, then I put to pin B negative motor instruct, which will send it a positive number then. If it's above 51 to 255, then it'll send to motor pin forward the instruction without a negative sign because it's already a positive number. And then anything between here, it's just zeros. So here's my, ignore this for now. So if I go up, it goes one direction. If I go down, it goes the other direction. And I have some analog control. Now here's the other direction. It's hard to go that slow to where you can really see it because the motor just spins right up without any load to keep the torque down. I'm still using my hbridge, and as you can see, I have now a joystick capable single motor that goes each way. Now that's not really my goal. My goal is to figure out the equation and program in the equation for the kinematics associated with, I forget the terminology, differential drive control, which is a way to drive this kind of vehicle with two wheels, each hooked up to its own motor. So when you turn while traveling, one motor has to spin a little faster than the other motor, and that's called differential drive. And it's not that terribly complicated of an equation. It's much simpler than my leg equation, but I only just started looking at it a little while ago, and I had never really wired even this rig up yet, so I wanted to work my way up slowly here, where I'm playing with these different control options. You know, for example, really I want this analog control potential on a wireless communication from one Arduino board to the other Arduino board, and my robots will be down there and my controller will be up here, and without using an XB shield, I might be able to even make, a receiver and transmitter out of discrete components, which would be freaking badass, and I would be so cool if I did that. But I guess I'll take it one step at a time and see if an XB shield is wicked cheap. But plugging so many shields, they stack, but they don't stack because you got to plug all these wires into them. So it's like, well, I don't know about all that business. I think I just want my one servo shield that's going to go on there and hook up to all these legs. And for this vehicle, I don't want any shields. I just want a couple H bridges, and then I want a receiver that can translate this kind of analog. It'll send a pulse width modulated signal into some kind of transmitter, which will amplify that pulse width modulated signal, which should really be simple, really basic stuff. Since this is all built, the circuit that will transmit one pin's output to another pin's input. I don't know how that'll work, because how is it going to know that that's what it's supposed to be getting? And how is it going to know that the other signals that you send aren't it? Anyway, maybe I can use frequency. Maybe I can use amplitude modulation to encode the signal. And then pulse width modulation to carry the information. I don't really know how that works. Anyway, they make XB shield that you can buy for probably relatively cheap. And for the interim, I'll just get some nice long wires and drive my robot like that. And try to program it to be like an autonomous behavior, some kind of behavior. I don't know. I got this sensor. Everybody hooks it up to be a pretty easy obstacle avoidance robot. I'll probably try to hook that up to this guy over here. This guy's just only the wires now onto those motors. And it's big, but I need it to be that way because I want to put these really big things on there. Right, so this is I'm playing with because it's got low power requirements, and I don't have the Darlington transistor arrays to drive these fat high performance motors. And I don't have the power set up in this little tiny board. This power supply can power this little tiny motor, and this is exactly the same thing. I mean, that's what this little thing is. I could really do things with that, but it would be so much work to try to fit everything onto that little tiny board. I could just get a board like that, put these big huge things on there, everything would be groovy, and it would be better.